All right, problem 42. So say for the system of equations given, and this is the system of equations they give, they say x minus 4 is equal to z. They say y minus x is equal to 8. And that 8 minus z is equal to t. 8 minus z is equal to t. So they say for the system equation, what is the value of z? So we're trying to figure out z. In the statement number 1, they tell us that x is equal to 7. X is equal to 7. Well, if we know x is equal to 7, we can solve for z right here. Because x is 7, then 7 minus 4 is z. So 7 minus 4 is 3. So z is equal to 3. That was pretty straightforward. So 1 alone is sufficient just using this first equation in the system. So let's see if 2 is of any use. T is equal to 5. T is equal to 5. Well, this is easy one too. You put t is equal to 5 right here, and then you could easily solve for z, right? You get 8 minus z is equal to 5, and you can solve for it, but I'm not even going to do it. You just have to know that you can. So this alone is sufficient as well. So the answer is D. Each statement alone is sufficient. Problem 43. 43. Is x equal to 5? Is x equal to 5? And statement number 1, they say x is greater than or equal to 5. Well, that doesn't tell me whether x is equal to 5. It just says it's greater than 5. Statement number 2 tells us x is less than or equal to 5. Once again, that does not tell me whether x is 5. But if I told you that both of these are true, x is greater than or equal to 5, and, not or, and x is less than or equal to 5, well, actually, that's still, well, the only x that satisfies that equation, that satisfies both of these, is 5. Right? I mean, you put 3 in, 3 will not satisfy this one. If you put 7 in, 7 will not satisfy this one. So the only thing that satisfies it is both, is 5. Sorry, my brain's malfunctioning a little bit. So you need both of these. So the answer is both statements together are sufficient. C. That one's confusing because it's so simple on some level. 44. 44. The table above shows the distance. Let me see if I can draw this table. Oh. Then they write R, S, T, U, and R, S, T, and U. They have a bunch of things. I don't even know what these are yet. I haven't read the question, but let's see. 0, Y, X 62, Y 0, 56, 75, X 56, 0, 69, and then 62, that's a 6, 62, 75, 69, and 0. And what are they going to ask? They're saying the table above shows the distance in kilometers by the most direct route between any two of the 4 cities. For example, the distance between city R and city U is 62. Or if you said between U and R, it's going to be 62 as well, right? That's the same thing. Fair enough. What is the value of x? So the value of x is the distance between T and R. Let me circle that. They want to know what the value of x is. It's the distance between T and R. So it's that one. And another way to look at the distance between T and R, that's this one. So these are both x. Fair enough. Okay. So statement number 1 tells us, by the most direct route, the distance between S and T, so we could say the distance between S and T, I'll just say it's line segment ST, is equal to twice the distance between S and R, is equal to 2 times SR. So let's see, do we know what SR is? SR is equal to Y, right? And ST is equal to 56. We figured that. So ST is 56. Let me do this. ST is 56. Between S and T is 56. So 56 is equal to 2 times SR. the distance between S and R is y, or S and R is y. So it equals 2y. And so we can solve for y. Y is equal to 28. And we actually didn't have to solve it, but let's see. I'm just trying to see where this goes. But that still doesn't help me figure out the distance between, what did we have, between R and T. That just helps me solve for y. Y is 28. Y is 28. Statement number 2, see where this is going. By the most direct route, the distance between T and U, so the distance between T and U is 1.5 times the distance between R and T. R and T. So the distance between R and T, this is the interesting thing, because this is our R and T is x, right? So they're saying the distance between T and U is equal to 1.5 times x. And what's the distance between T and U? The distance between T and U is 69, right? The distance between T and U is 69. So you have 1.5x is equal to 69. You don't even have to solve it. You just know that you can easily solve for x if you know statement number 2. So statement number 2 alone helps you figure out what x is. Statement number 1 is fairly useless. So the answer is B. Statement 2 alone is sufficient. Draw a line here. I don't want to. Okay, problem number 45. 45. What is the value of the 2-digit integer x? So 2-dig integer x equals, who knows? All right. Statement number 1. The sum of the 2 digits is 3. So let's say that x is equal to the number a, b, where this is the tens digit and this is the ones digit. So statement number 1 says the sum of the 2 digits is 3. So a plus b is equal to 3. Well, that doesn't help us. There's a lot of, well, you know that these are going to be positive numbers, but we don't know whether they're two different numbers. 2. X is divisible by 3. X is divisible by 3. Well, I don't know if you learned that trick in school, but any number that's divisible by 3, the sum of their digits add up to, the sum of their digits are also divisible by 3. So once again, that just means that a plus b is equal to some multiple of 3. Well, if you keep adding them, they eventually add up. So if you had a 2-digit number, so this, let's see. Let's think. Just a plus b is equal to 3. This could be a couple of different things. You could be, see, a 2-digit number. I mean, it could be 30, 30. It could be 1. It could be 12. It could be 21. I think those are all of the possibilities that we can have just off of statement number 1. And x is divisible by 3. Well, all of these are divisible by 3. So really, both statements give you no information. So the answer is E, that both statements combined still give me nothing. But all of these are possibilities. And actually, this one leads to many, many more possibilities that x is divisible by 3. Because then you could have things like, I don't know, this would have been a valid number as well. So this would actually give a lot more. This is a little bit more restricted. But anyway, either way, we can't figure out what x is. It could be 30, it could be 12, it could be 21, it could be anything. All right. Problem 46. What is the tenths digit in the decimal representation of a certain number? So the tenths, that's the number right behind the decimal point. So the number, let's just call it x. So statement number 1 says x is less than 1/3. And 2 says that x is greater than 1/4. So is this enough to figure out what the tenths digit is? So what's a number that's less than 1/3? Let me just think of a couple of them. Well, 1/3 is like 0.3333 repeating. So if I just write 0.32, that satisfies 1, and it satisfies 2, right? 0.32 is greater than 1/4. But what's another, and then in this case, the tenths digit would be a 3. But let me try to find another one that would satisfy these both. Well, let's see, greater than 1/4, what about 0.26? 0.26 is definitely greater than 1/4, and is definitely less than 1/3. But both of these have different tenths. One has a 2, one has a 3 there. So even both statements combined still do not allow me to solve the problem. There's not enough information given. So once again, E. Together, I'm still not getting enough information. Oh, I'm almost at 10 minutes. Anyway, I'll see you in the next video.